Welcome back to Math in the Bubble with Mr. Daly. We're going to call this episode 7, even though we've probably missed 2 or 3 in there, but we're going to start on a new topic today, which is called linear equations. And so linear equations, you can just think of them as line equations. So that word line is inside linear. It's a fancy word for line equations, really. And you're probably familiar with this equation, y equals mx plus c. So this is the general form of a line equation. So it's made up of 4 parts. So there's the y, that's your y coordinate. Then you've got your x is your x coordinate. So, and then you've got your gradient. So that's your slope of your line. And you might remember rise over run. That's the one thing that seems to always stick in my head is rise over run. And I always come back to that. And then C is the point where the line crosses the y-axis. Alright, so any line that's on an x and y axis can be made using this general form of the line equation. Alright, so to start us off, we're just going to look at some basic lines. I'm just going to try and get this nice and see if I can zoom in on my camera a bit. And get that on the right spot. Alright, so I'll use blue pen. We'll focus on the blue line for a start. So the easiest thing to get from your line equation is the y-intercept. So each one of these marks, I've only labeled 5, but that's because your math books are locked off into groups of 5 squares. So whenever I'm doing a axis, I never number these numbers in here 1, 2, 3, 4, 5, because it's better just to count in 5s. It just looks a lot tidier, and it's easy enough to use these thick lines in your math books. So anyway, I'll just write the 2 there just for the sake of it this time. So 2 in this case is going to be our C. So I'll just put that at the end. We've got an equals there. We've got a y equals mx plus. Oops, that's just a little bit off the thing. So I've just put the y-intercept where there is a c, and I've still got to figure out my gradient. So the gradient is always how you can pick any 2 points on a line and just go up. So this is your rise, and then you come across. This is the run. So our gradient equals rise over run. So it's over as in division, right? It's basically a fraction, the gradient. So we have risen 1, 2, 3, 4 squares. So our rise for this one is 4, and our run is 1, 2, 3, 4 squares. Well, I meant it to be 4. It's not the best ruled line. So 4 over 4 is 1. So in this case, our equation is y equals 1x plus 2. Sometimes when you're given questions, they might actually exclude that 1. So this is actually the same formula. But y equals 1x plus 2 is the equation of that line. Alright, I'm going to change pen to the red one. So the red line crosses through -4, right? So our C part is -4, and we don't know what our gradient is. We've got to work that out. So we just want to draw a triangle onto our anywhere where it sort of crosses our grid lines will do. So any line that goes into the negative zone, so it's running, is that the best way to say it? Well, you got to always think right to which way you're going. So if we started here, we're going down. Now down is negative, so we've gone down -4, and then we've gone across +2. So our rise over run in this case is -4 over +2, which equates to -4 divided by 2 is -2. So our gradient comes in there, and our full equation is y equals -2x minus 4. Alright. Last one, the green one, green line. So the green line crosses here, and that is, where's a good spot to squeeze this? Maybe I'll do it out here, just showing you don't always have to do it on the right side. Oh, but that's so ugly out there. Ah, well, I'm just going to make 2 points. So if I just draw a triangle onto this, then we want to go from here on the line to 0. We've gone down 2 and across 1, 2, 3, 4, 5, 6. So +6. So for our green line, our gradient equals our rise is a negative, so we've got -2. Going down is negative, and then across 6. Rise over run is equivalent to -1/3. So -2/6 is the same as -1/3. So quite often you'll get your gradient as a fraction, but you can think of it just for every one it goes down, it goes across by 3. So down 1, across 3. You can put that anywhere on the triangle. Down 1, across 3. I mean, if I'd drawn it perfectly, you could do that, but that you could think of that's the same as down 3, across 9. So if I went down 3 and across 9, then I've essentially done the same thing. So you don't always have to do it in 1s or 2s or 3s. Just whatever you feel like you want to go down in the rise and across in the run will get you the right gradient. Alright, so this is the most simplified equivalent fraction, so we'll use that. -1/3 x, and our intercept is at +5, so we got a +5. Right. How's that go? Let's move on. I'll just zoom out a bit. Alright. Okay, now I'm going to do the reverse. So we're going to plot the lines rather than find the equation from a given line. So for one way to plot the lines is to sub x values into the equation. So we put in x equals 0 in here, and it'll give us a y value. So by subbing that in, you can see why this is always the y-intercept, because 3 times 0 minus 8 is just going to give us minus 8. So that's why we get our y-intercept for our blue line going through minus 8. And then you can do that for any number, and it'll figure it out where that would be on the line. So I may as well just choose 1 for interest sake. So essentially I'm substituting in x values, right? I'm making up a little table so that I can plot points. So 3 times 1 minus 8 equals negative 5. So we're going to have at x equals 1, y equals negative 5. So you get another mark there. For 2, if we go 3 times 2 minus 8, that equals negative 2. So when x equals 2, y equals negative 2. So x equals 2, y equals negative 2. And you can also already see that all these points are lining up along the same path. And they seem to be going over 1, up 3. So they're running 1, rising 3, which reflects our 3 gradient. Now you don't always have to count up even numbers. You can put in a 5, which is much further down the line. It should still end up wherever the line is. So I might just draw the line in and show you how it lands on that line. So that's I mean, it's probably going to miss it by a slight amount because I haven't ruled that very good. But anyway, let's just keep going. So we're subbing in x equals 5. So 3 times 5 minus 8. 3 times 5 is 15, minus 8 is 7. So when x equals 5, y should equal 7. So it should have gone through there, but you could put that down to not ruling well. Okay, let's do another one. So yeah, often it's good to find a point that's further along and rule between that point and another point way over here. So if we found negative 1 and 6, then we could draw a really accurate line. So the further out you space your lines, your points, the more accurate you can rule through them. Alright, let's do y. So if we start with 0, 1/2 times 0 plus 3 is just going to be 3, because that essentially cancels out our x term. So this gives us our y-intercept, which is here. X equals 0, y equals 3. If we go 1, we're going to get 1/2 plus 3, so we're going to get 3.5 or 3.5. So that's kind of there. Now we can sort of see what's happening here. but it's not, the line's going to shoot out here, but we don't want to keep going across by a half each time. We know what's going to happen. We want to sort of know what's happening around x equals 10. So let's try x equals 10 so we can get some points that are far enough apart that we can rule an accurate line through. So when x equals 10, a half times 10 is 5, so that would be 5, plus 3 makes 8. So when x equals 10, y equals 8. So it's going to go right through where I've just written. And we could also test a, so if just judging from this, it looks like it might go through -8. So let's try that. Or -6. X. So when x equals -6, -6 times a half is -3, plus 3 is going to get us 0. So we're going to also have a point out there. So you don't have to just go 0, 1, 2, 3. I mean, start out like that, but use those first 3 to just sort of gauge, oh, okay, or maybe I should choose a point out here. So make informed choices. I'll just get the ruler. I think this ruler's been in my dad's garage for 30 years. It's pretty old. It's pretty cool though. Basically it's a meter long ruler. Folds up. Alright. This one. Now this is a pretty, oh, I need to move up. Just get, so with a nasty fraction like this, we want to choose numbers for x that are gonna give us nice round numbers that go through the points. So you can think of a fraction as 5 divided by 6. So when you're dividing by 6, numbers that cancel out a divide by 6 are a multiply by 6. So we could multiply by 6 and it would cancel out a divide by 6. If we multiply by 12, that would also sort of cancel out a divide by 6, and 18 and so on. But we don't have 18 on our graph, so we'll just use 6 and 12. We have to make 12 out there. We could do -6. So for a start, if we sub 0 into there, we're going to get -5 6 times 0 plus 7. So that essentially cancels that all out, and we're just left with our y-intercept plus 7. So I'll plot all these at the end. So this equals 7. For our next value, 6, we're going to get -5 divided by 6 times by 6. So a divide by 6. Oh, I think my drawer cam just broke. How's that going on the stream? Oh, there we go. It's back up. Alright. So where was I? -5 divided by 6 times by 6. Those 6's end up cancelling out. And we've still got that plus 7 part. So -5 plus 7 equals Last one, -5 divided by 6 times 12. So 12 divided by 6, that's 2. So -5 times 2 plus 7 equals -3. But of course, you can do this with your calculator and do it a lot quicker, because you can just basically change that number and it will just work it out for you without you having to do all the math in your head. Okay, so, wait, was that right? -5 times 10, so that's -10, yep, right. So we've got 0, I'm going to plot these points now. See if I can get all this on one page. Might have to zoom out a bit. Okay, I might just draw this. So from this first one, we got 0, 7. And the next one, we got 6, 2. And then we got 12, -3. So 0, 7, that's where it crosses the y-axis. 6, 2. So here's 6, 2. And I've just gone across to 12 here. There's 12. 12, -3. So down 3, there. Okay. Now if we roll those up. There we have it. -56x. Okay, that concludes that. Now I'm going to show you guys what I would like you to do for homework. It's a online Desmos activity. So I'll just change over to sharing screen. There we go. So I don't need my Droid cam anymore. Alright. Okay. So in this week, there's a link to an activity called Desmos, and the code that you put in is NXRZZR, right? So it'll bring you to a link and you put in that code. Caps lock on NXRZZR. Then you just sign in with your Google account or your school account. Oh dear, I'll sign in with Desmos. Maybe I'll just use that one. Well, what's going on? Anyway, I think I know why that is not working. It's because I already signed in on another application, didn't I? Maybe I need another tab. Let's try n x r z z r. Let's go. All right. So this game is about making lines, and you've got to try and get a line that is going to go through all these coins. So this is the first one, just showing you how it works. So there's this line, a half x plus 1. Let's do another one. Okay, so I want to get a line that goes through these coins. So that's going across 1, up 1, so it's just going to have a gradient of 1. So y equals 1x plus, and then its y-intercept is at 3, so let's try that. So that's going to get through those lines. Add another line. So this next line is going to go through positive 1, and it's got a gradient of, well, it's a rise of 1, 2, 3, 4, 5, 6, and then across 2 over 2, 6 over 2, so 6 over 2 is 3. Y equals 3x plus 1. Yeah.